So let us look at this question. In this question, you're given a circle x square plus y square is equal to 25 and 3x plus 4y is equal to 20. And you're asked to find a point on this circle which is at a distance of 1 unit from this line. So you have a circle x square plus y square is equal to 25. The center is origin and the radius is equal to 5. So this point is 5, 0. This point is 0, 5. Now if you take this line, 3x plus 4y is equal to 20. The x-intercept is 20 by 3, that is 6 point something, and the y-intercept is 5. So this also passes through this point and has a x-intercept of some number greater than 5. So let us draw the line. Now if you take different points on this circle, they'll be at different distances from this line. If you take different points on this circle, they'll be at different distances from this line. So you're asked to find that point which is at a distance of 1 unit. When you draw this to scale, I want that point which is at a distance of 1 unit from this line. So how do we solve this? So what is the first step? So you can start with let the required point, because you're asked to find the point which satisfies this condition. We assume that the point B, let the required point be h, k. So let the required point be h, k, which is on the circle. Or you can also assume this as r cos theta, r sin theta, if you want to use the parametric form. R is 5, so 5 cos theta, 5 sin theta. Now if you use this point, you'll have to deal with equations in 2 variables. If you use this point, you'll have to deal with equations in 1 variable. So this is 1 variable question, this will become 2 variable question. And the second thing that you need to observe is, if you take this point, you'll be dealing with algebraic equations. If you take this point, you'll be dealing with trigonometric equations. Trigonometric equations are slightly more tricky than algebraic equations. So there are pros and cons for both these points. If you take this point, you have 2 variable equations, but you'll have algebraic equations. If you take this point, you'll have single variable equation, but you have a trigonometric equation. So let us try to see both of them and try to observe which is better and the reasons for that. So first let us take the parametric point and see. So if you take the parametric point, you have only one unknown, you'll have one condition. I want this point to be at a distance of 1 unit from this line. So the line is this, the point is this. What is the distance of this point from this line? The perpendicular distance of a point from the line. We have derived the equation in the straight lines chapter. So modulus of, you just need to substitute x and y in the place of x and y. So 3 times 5 cos theta, 15 cos theta plus 20 sin theta minus 20 by root of a square plus b square by root of 3 square plus 4 square is equal to, the distance has to be equal to 1. This implies, if you take a 5 common from this, 5 times 3 cos theta plus 4 sin theta minus 4 by 5 mod is equal to 1. This 5 and 5 gets cancelled. So mod of this is equal to 1. This implies 3 cos theta plus 4 sin theta minus 4 is equal to plus or minus 1. This implies 3 cos theta plus 4 sin theta is equal to, if you send 4 onto that side, 4 plus 1 5, or 4 minus 1 is 3. So 3 cos theta plus 4 sin theta is equal to either 5 or 3. So you need to solve this equation. and let us try to do that. So the first equation is 3 cos theta plus 4 sin theta is equal to 5. This is a very specific trigonometric equation of the form a cos theta plus b sin theta is equal to c. So what do we do in these type of equations? We divide both sides by root of a square plus b square. Root of 3 square plus 4 square is 5. So we divide both sides with 5. So 5 by 5 is equal to 1. So 3 by 5 cos theta plus 4 by 5 sin theta is equal to 1. Now let us take a triangle, a right angle triangle, whose sides are 3 and 4. And let this angle be equal to alpha. So in this triangle, this side will be equal to 5. So now in this triangle, 3 by 5 can be written as cos alpha, 4 by 5 can be written as sin alpha. So this side is of the form cos theta cos alpha plus sin theta sin alpha, which is cos of theta minus alpha is equal to 1 is nothing but cos of 0 degrees. So this implies theta minus alpha is equal to 2n pi and theta is equal to 2n pi plus alpha. So this is one value of theta, and correspond to this value of theta, what is the point? R cos theta comma R sin theta. So the required point is 5 cos theta comma 5 sin theta, right? That is equal to 5 times cos 2n pi plus alpha is cos alpha. 5 cos alpha comma 5 sin alpha. And what is cos alpha? 3 by 5 into 5 is 3. Sin alpha is 4 by 5 into 5 is 4. So this is 1 point. So that means you have 3 comma 4 in the first quadrant, which is at a distance of 1 unit from this line. Now let us go to our next equation. So 3 cos theta plus 4 sin theta is equal to 3. This is also of the form a cos theta plus b sin theta is equal to c. So here also you can divide both sides by 5. So that is one way. But here you have a speciality. This number and this number is turning to be equal. So if these two numbers are equal, you can do something which is slightly easier than this method. What I do is 4 sin theta is equal to 3 minus 3 cos theta, 3 times 1 minus cos theta. This implies 4 times sin theta is 2 sin theta by 2 cos theta by 2 is equal to 3 times 1 minus cos theta is 2 sin square theta by 2. So 2 sin theta by 2, 2 sin theta by 2 gets cancelled. 2 sin theta by 2, 2 sin theta by 2 gets cancelled. That means you get 4 cos theta by 2 is equal to 3 sin theta by 2. Right? 4 cos theta by 2 is equal to 3 sin theta by 2, or sin theta by 2 is equal to 0. So whatever term is getting cancelled, that is equal to 0 is also a solution. So this implies tan theta by 2 is equal to 4 by 3, or sin theta by 2 is equal to 0, theta by 2 is equal to n pi, theta is equal to 2n pi. So theta by 2 is equal to 0 implies theta by 2 is equal to n pi, theta is equal to 2n pi. So this is one solution. Theta equal to 2n pi is also okay. Next, tan theta by 2 is equal to 4 by 3. So if tan theta by 2 is equal to 4 by 3, what is sin theta and cos theta? So sin theta is equal to 2 tan theta by 2 by 1 plus tan square theta by 2, and cos theta is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So that is equal to 2 times 4 by 3 by 1 plus 16 by 9. 1 plus 16 by 9, that is 25 by 9. So 3 and 3 gets cancelled, 3 goes up. So 2 4s are 8, 3s are 24. So 24 by 25. And cos theta is 1 minus 16 by 3 by 1 plus 16 by 3. So you get 1 minus 16 by 3, sorry 16 by 9. So minus 7 by 25. So you got 3 different values. So 1 point is 3, 4. Corresponding to theta is equal to 0. 2 and pi, if n is equal to 0, theta is equal to 0. So corresponding to theta is equal to 0. What is the point? 5, 0. 5 cos 0 is 1 and 5 sin 0 is 0. So the second point corresponding to theta is equal to 0 is 5, 0. The third point comes when you have these values. That is 5 times cos theta minus 7 by 5, 5 times sin theta 24 by 5. So that means you have one point somewhere here. The other point is 5, 0. And the third point is in the second quadrant. Minus 7 by 5, 24 by 5. So from the diagram also you can see you have one point on this side. 2 symmetric points on this side and this side. So the required points are 3, 4, 5, 0 and minus 7 by 5, 24 by 5. So using parametric equation or parametric form of the point, we have solved this question. Now imagine that you need to solve this using the general point HK. So how do we solve it? So if you take the general point HK, the first equation is that the distance of HK from this line has to be equal to 1. This mod of 3h plus 4k minus 20 by root of 3 square plus 4 square is 5 is equal to 1. And the second equation is h square plus k square is equal to 25. That is, this h comma k should lie on this circle. Now from this, 3h plus 4k minus 20 is equal to plus or minus 5. This implies 3h plus 4k is equal to 20 plus 5 is 25 or 20 minus 5 is 15. So this implies you have a linear equation in HK and a quadratic. So first let us take h and substitute in this equation to convert this completely into a quadratic. So 4k is equal to 25 minus 3h or 15 minus 3h. So k is equal to 25 minus 3h by 4 or 15 minus 3h by 4. So you take this k and substitute in this equation. So h square plus 25 minus 3h by 4 whole square is equal to 25. So you solve this equation, you get some values of h, 2 values of h. And you take the second equation, h square plus 15 minus 3h by 4 whole square is equal to 25. So you have to solve this quadratic and this quadratic. From this you might get 2 values of h or 1 value of h depending on the number of roots of this. Here also you might get 2 values or 1 value depending on the type of equation. So once you get h, if you substitute h in the equation you get k. So correspond to h you get the values of k. So as you can see, this is also not very difficult. It is also easy. So you have advantages for both the methods. In the parametric method, the number of variables, the number of unknowns is small, but the type of equations are trigonometric equations. In this, the number of variables are more, but the nature of equations that you get is algebraic. So you have to decide which is better in the particular case of the question. Thank you.